Hello, everyone. This is Kristen Huber, and on behalf of 451 Research, I would like to welcome you and say thanks for attending today's webcast titled OpenRAN Security, the Benefits of OpenRAN for Security of the Network. Today's interactive discussion will be moderated by Eric Hanselman, who is Chief Analyst at 451 Research. Eric coordinates industry analysis across a broad portfolio of disciplines and is a member of 451 Research's Center of Excellence for Quantum Technologies. I have a few housekeeping items before we get started. To ask a question, simply type it in the question box on your screen and we'll get to as many as we can. The presentation slides are loaded in the resources section on your screen and ready for download. And finally, please check back for the on-demand version of this webcast after the conclusion of the live event. And with that, I'll turn it over to Eric.
Thanks, Kristen. We've got a topic today that I think has been on everyone's minds in terms of the evolution of mobile networks broadly, how we get to a better security footing. And we've got a great panel of participants in this market. We've got some interesting views in terms of what's possible and directions that can be particularly useful for operators in terms of what we can actually accomplish. So we'll be talking about some of the benefits of OpenRAN security, the integration of virtualization and what that really means, getting into some of the benefits of openness generally in a panel discussion that will actually start to work through a whole set of these issues and potential benefits. And then we're going to open it up for a Q&A session at the end. So please send in your questions. As Kristen had mentioned, there's a Q&A button on the bottom of your screen, and we'll try to get to as many as we can. If we're run out of time, we'll certainly answer all of those in follow-up attached to the on-demand webinar when we get going. So if we think about really what the challenges are that we face in radio access networks today, fundamentally it's that the security problems that we're trying to address are complicated. The RAN environment, to a much greater degree than other aspects of operator environments, has a whole set of different pieces given the scale, given the dispersed network of the environments we're actually working with, given some of the policy concerns, and most importantly, it's the actual interface into that whole expanding device ecosystem that is really starting to expand in ways that's difficult to manage and present a whole set of new challenges. Open approaches to RAN environments offer some very specific advantages. They offer the ability to expand ecosystems for radio environments and to be able to look at how they're deployed and managed in ways that are more granular and modular, ways in which you can actually start to address a whole set of new capabilities and mix and match capabilities and components in ways that are more challenging in proprietary environments. It gives operators the ability to increase their supply chain diversity, to be able to get to a footing that allows them to have broader selection, to be able to introduce new technologies, and to be able to take advantage of advancements in those technologies much more rapidly in their environments. It also depends on a lot of the benefits that get rolled in through virtualization. Some of the visibility and the observability that can be garnered from an environment that's actually throwing off significantly greater telemetry and making that telemetry more easily accessible. In these new worlds of radio networks, I think there's been a lot of thought about sort of transitions to 5G, but we see the densification of 4G as also being another area that's not only creating challenges, but are issues that have to be dealt with today. There are also changes in the landscape in which the operators are functioning. Attack sophistication is increasing. If we look at the increasing capabilities of the tool sets that attacker communities have at their disposal, and the expanding access to operator networks that are being driven by interfaces to handle things like IoT, as we start looking at vehicle communications capabilities, that expanding infrastructure is opening the doors to new modalities of interaction, new capabilities that those networks are supporting, but they also increase the attack surface. And they do it in ways that are being stressed by the additional scale that these environments have to offer. These set of challenges can be daunting for operators. They try to figure out how they're actually going to manage this. open approaches to all these capabilities can give them options simply because they've got a wider set of suppliers. They can reduce their dependency on any individual supplier in that chain. So getting out of some of the monoculture issues that we get from a security standpoint. It also gives operators the ability to have much greater operational control, to actually grab the reins and guide their own destiny in terms of actually understanding what's running on their network, what its current state is, and the transparency to actually understand what all these elements are, how they're functioning, and whether or not they're actually functioning in the way in which they expect them to be able to get visibility and transparency into those environments, to be able to increase their security standing, and to be able to be more effective in terms of how they manage that. So to talk about all of these capabilities, the possibilities, and the benefits that are going forward, we've got a great panel assembled. Let me introduce them to you. From Altiostar, we've got Sunil Puthyandil. We've got Mike Geller from Cisco, Udayan Mukherjee from Intel, Azhar Syed from Red Hat, and I'm Eric Hanselman, your moderator. So let's kick off the discussion and start getting things moving here. The first thing I'd like to put to our panelists today is just to talk about and quantify what are some of the most significant security challenges that we face in radio networks today. So for each of you, where do you want to start? Sunil, why don't we start with you?
Can you hear me?
Oh, yep, now we can hear you.
Right. So in my opinion, and our kind of experience with customers, so couple of areas, right? Major challenges happening in the OpenRAN or RAN domain. First thing is when you put these radio nodes remotely in geographically distributed site, right? These sites are right, maybe small data centers or remote sites, just a pole where you are really having that radio unit. So those things are in open. There is no real physical security, right? It is important to really assume a zero trust model. Like you don't even know, right, whether this particular radio unit is a rogue or something you can trust. So you need to really secure all those remote radio units and make sure that those are really authenticated and connecting to your core network. So that's one thing, right? The second thing is basically also when you really take this virtualization and OpenRAN, really taking various pieces, right? Hardware layer, various software virtualization, and different applications. Again, you are really bringing in many layers and really integrating. You again need to really assume there is no real trust there, so that you have to ensure these are all right authenticated and secured, so that you have an overall security for your network.
Both of your points are really talking about trust. And I think one of the most important things about open environments is the ability to actually return control of how that trust is established to the operators themselves. In proprietary environments, that's a little more challenging. And that's an area I think that's probably one of the bigger pieces that adds particular value. Now, for other panelists, Mike, are there things from your perspective that are aspects of trust and things that step beyond that in terms of where we're really headed with this?
Yeah, so I think the answer from my friend on the panels who just spoke is dead on. You know, it starts with a level of trust. You know, really, we've moved to a deployment methodology in the networks that we're building around a model of zero trust, right? So there's a lot of innovative approaches that are being brought to the use of PKI, innovative use of PKI technology to establish trust at a number of different levels and places in the network. As you mentioned, the 5G standard does cover some of it, but there's other parts of it that a lot of the a lot of the OpenRAN or OpenVRAN kind of participants have brought from an innovation point of view to go in and take that steps further. And when you look at it, then you build on that foundation of trust, and you then establish from a very rigid PKI perspective, who can attach to the network, where they can attach, how subscribers and users get put into different slices, and you look at that pervasive aspect of the application of that trust technology from the hardware and software that make the services run, to the way that they are service chained together, and you deliver those cloud native outcomes, for example, in a throughout the packet core in a standalone architecture. And I think what we're starting to see is sort of a benefit of many cooks, many chefs in the kitchen, so to speak, for this, and the innovation level of trust that can be brought to the overall to bear to make things more secure that way. I think also, though, you're also starting to see then different applications above that trust, in a more of a layered approach, and an ability to bring solve a lot of the security problems by bringing many more eyes to the overall problem space to in a very rapid way solve problems there. I mean, there's a corollary challenge that comes with that, but I think the benefits so far in early returns have far outweighed the challenges in that respect.
Well, you've raised some interesting points on the benefits, and I want to dive down a little deeper on the cloud-native pieces in just a sec, but I want to make sure that we also get some perspectives from Udayan and Azhar as well.
Yeah, Eric, I think both Mike and Sunil hit it right. So essentially, RAN is the first entry point to your network. So as you know, and this is not just 5G or 4G, all these intelligent devices now are getting connected. So what do you do about this? So there are 5G itself brings in an end-to-end security model, not a retrofit, as an architecture, as a spec. Things like SUPI, the subscriber information, and ID. There are a whole bunch of security features that are built into the new standard. But overall, from the architecture, OpenRAN perspective, things are actually, when you have the ecosystem diversity and you have open front halls and open systems, it increases the visibility. And, so that brings up another level of control, that you know exactly what is happening in the systems. And as Sunil talked about that, okay, you have to bring the data in many cases of this pooling in some centralized places. Yeah. So there are a lot of built-in the security in the transport network. Traditionally, in our cloud technologies, we have been used, the IPsec, the cryptos, the NMA, the MACsec from the Ethernet side of it. So there are a lot of those technologies that now we can bring to bear to actually address security and trust.
And are there other areas in terms of the challenges that we haven't addressed yet?
So,
you guys.
Thanks, Eric. Thanks, Eric. I think, the panelists spoke earlier on different aspects of different radio devices in multi-vendor environment, particularly in OpenRAN space. I think one aspect that I can bring in front of the audience is, infrastructure. How do you, secure, deploy, manage the infrastructure to ensure that there is an OpenRAN, environment out there with multiple different vendors integrating at different levels. We have some specifications that are available. We have some reference implementations that are available, but there is an infrastructure layer of security too that needs to be taken care of, and I'm sure we'll get more into it as the conversation goes on. And in terms of establishing that particular trust and authentication capability, there are interesting new open source projects that are spawning up in order to particularly address this kind of remote node deployment, remote boot attestation, managing the security from a telemetry perspective, and more importantly, as you get all of this data, correlating them. And I think we'll get into that conversation further on in the call.
Oh, well, yeah, actually, I think you're aligning with some of Mike's points about, being able to leverage some of the cloud native benefits and to be able to build them on top of what is a secure infrastructure foundation. But yeah, to your point, we'll talk to that in a little more detail. I want to actually pick up on one of the things that Dan was saying. One of the things that we hear from a lot of our clients is this expectation that a lot of the new security improvements that are coming in 5G architectures are really their end goal. But my take would be that there's still a lot to do with existing environments, especially as we look at densification of 4G. And my concern is that if we start to put off some of these changes to whatever that bright, happy 5G future winds up being, we're missing out on a lot of potential upside in the near term as well. What are your thoughts about that as well?
Yeah, you are correct. I mean, a lot of deployments will continue on 4G or even previous generations. So essentially, as we talk about the OpenRAN and the other initiatives, and it addresses LTE elements as well. So essentially, many of those, as you get to a cloud, cloud native principles, you can enhance these elements of it. For example, some of the transport stuff we talked about, bringing the data, somewhere in. So there may be some concerns on those elements of it. So there are well-defined, technologies that traditionally all of our, cloud vendors and traditionally Facebooks of the world, Googles of the world, we've been using for years. So we will bring those in, and that is already being deployed. I mean, which is public knowledge. I mean, the first deployment of some of the virtualized platform is happening in Japan with Rakuten, and I think that's going on live next month. It's publicly announced. So those are in LT to begin with. So security is key, and some of the same principles, the open interfaces and definitions and protection. So with the cloud native technologies can help there as well.
We provided a good entree into some of the benefits of openness and open approaches. I'd like to explore how open approaches are increasing visibility. I've heard each of you talk about increases in visibility through expanded telemetry, better transparency in terms of understanding what's actually running your network. How can this sort of open approach improve an operator's security posture? And I'll open the floor to anybody who wants to dive in first.
Yeah, so it's Mike. I'll take a swag at that one. So look, an open approach has both many benefits and has some challenges associated with it as well. We from an integration perspective and a testing perspective, we're coming together as an industry to have kind of a consortium type approach, where we're able to, get things tested and integrated and look at. I think a lot of the documentation from APIs and from other points of integration has been not only been put out there and has started to be socialized and implemented in some early trials and some early successes, but it's also produced some results around a formative early security architecture that goes with it, right? So when I think that open approach brings the best of breed and the smartest of approaches, and sometimes vetting out the less appropriate approaches as real implementations are both realized and tested and built. The challenge is the ownership as an industry of vulnerability fixing and things like this. But even we've started to come across and solutions to that, as an industry where we can develop against a specific agreed upon standard and finding and solving for bugs that way. A modular approach is we're finding is starting to get us to answers to security questions much faster, which is great. And I think that that open approach would continue to produce results in at that level. I think also the security controls have started to adapt and started to catch up to the challenges of size and scale and distribution that this architecture is demanding. So I think that's a good place to start.
Eric,
well,
if I may jump in.
Oh, yeah, by all means.
Sorry. I think what has happened and what has changed in the world is because of the enormous amount of compute power and the sophisticated security attacks, right? Sophisticated attacks on the infrastructure in terms of how they're being dealt with. The old concept of security by obscurity doesn't work anymore. And that was actually true in closed approaches, right? You didn't know what was in there, what was in the box, so hence you didn't know how to handle it, and hence it was considered inherently more secure. Well, that's gone. That's completely broken. That myth is, busted. So what has happened now because of the sophistication of those different security attacks? The only other option that's available to people is to be more open about things, which means open infrastructure, open, source adoption, where there are many more eyes looking at that software code, at those APIs, at those intersection points, where they can identify the problems before, hackers are able to identify those problems and actually exploit them. So that's what really the open approach brings to the table. Yes, as Mike said earlier on, it does bring in a challenge of, integration, but with the set of automation tools, with the set of, distributed integration pipelines, things are getting much better in terms of how a cohesive set of software is delivered from different vendors together to a telco.
Well, you're identifying some of the main benefits that get delivered by a more modular approach, by being able to go swap in and swap out capabilities. To your point, it does mean that there's an integration task that's involved to be able to manage that, but it seems like this is an opportunity that really gives operators the ability to have much more control over what's actually being deployed. Is that something that you're seeing in terms of those capabilities more broadly? And again, we'll open it up to the panel at large if any of you got perspectives on that.
Yeah, so I'll take a stab at it. A couple of things like radio vendors and now the base station or baseband vendors. Now, the opening up the, say for an example, a critical part of the ORAN is opening up the frontal interfaces. Just imagine, for the last 5-6 years, there was an attempt. Traditionally, it was the CIPRI, but IEEE started first, then XRAN, and now ORAN. Now that open frontal interface is opening a mix and match between the radios and the modularity of the base station system. So there's much more visibility. Traditionally, the CIPRI frontal, was loosely defined. A lot of those control messages are vendor specific. It's a black box to an operator. What the heck is coming? And now it's a well-defined specification that came, is now being released from XRAN, and now ORAN bless that. Is the, so it defines how you do the control, how do you do the synchronizations, how do you do the user plan. So those things are now quite visible for operators. So any kind of, malicious attempt or any kind of a effect of it, finding out something wrong is happening, I mean, you have more visibility on the systems and rapidly patching in your systems that you can do. So those are, some specific benefits that they are seeing, they are going to see. And by the way, Eric, you asked about the 4G as well. This is valid for the 4G as well, the split architecture and opening up this frontal.
Well, and this is a point at which now there's an opportunity for greater observability, so we actually can start getting into some of those pieces. So is this something that is exclusively the domain of virtualization, or are there larger benefits that step beyond this? It sounds like we're talking about a little bit more in terms of being able to actually now have defined and open interfaces. Can we garner some of that same operational visibility into how the individual components are performing, the individual functional elements are performing through visualization for virtualization? And what are those trade-offs with some of the proprietary approaches?
So I'll take a swag at that, and there was a question that was asked in the chat on from our friends at Globe Telecom around the role of firewalls in this whole thing. So what's happening here from a virtualized network perspective is that, especially as things move toward cloud native, is that you're starting to see the controls that we use. So we need to make sure that we have visibility. The role of things continuing to be encrypted is making where we get that visibility a little more challenged, which means that just the placement of a firewall as a security boundary sort of is no longer it's not dead. There are certain places in the network where you can still do it. But what's happening, though, is that those security controls are being sort of disambiguated into different containers and running microservices inside of containers that deliver specific security functions and outcomes. So for example, there might be an access feature, there might be a carrier-grade NAT feature, there might be other features that are required, and those things are being put together and integrated into control facilities like Kubernetes, and then gone and orchestrated by things like Robin.io and other approaches in the open source space, and some in the integrated vendor approach space. The whole point, though, is that there's not just an evolution of the RAN. There's an evolution in terms of the 5G architecture across the actual network in how those security features are both delivered and how they're validated and based on that trust architecture underneath that was mentioned, right? So I think we need to kind of take a step back and take a look at how the security controls continue to evolve and where they would be placed. Firewalls don't go away, but they also change in their form and size and where in the network those features get deployed. So I'll leave it to the other panelists, but maybe that's a good start for your to answer your question.
So thoughts from our other panelists. We're headed in interesting and new directions here, and do these controls start to take new and different forms?
So let me step in, Eric. Spot on, Mike, in terms of your comment and in terms of how functionality will move around as you disaggregate more components and move to a cloud-native model. I think the part that we need to look at from a holistic standpoint, as you virtualize or move to a cloud-native model in the RAN space, you have to look at it in three different segments and components, and then one is the infrastructure itself. How do you secure the hardware? How do you make sure that you have secure boot capabilities, remote boot capabilities, the concept of trusted platform that you need to establish first. Then there is a baseline platform capabilities that you need to secure from an operations policies perspective, right? This is to do with establishing roles, profiles, certificate management, and all of those contexts from an infrastructure perspective. Then you get into the actual network functions, network function chaining, and authentication of those network functions, and then you get into the controllers. And if you look at these four different layers, security has to be applied at all of those layers, not just one where you're just worried about a rogue radio module, or not just one where you're worried about just a secure operating system and a vulnerability patch. You have to look at both. You have to look at everything in the stack in terms of establishing that secure footprint. And particularly as you go out and distribute this with a virtualized RAN environment into smaller and smaller data centers, you have very smaller and smaller footprint devices. You need to be really careful in terms of how you design that infrastructure and how you manage that particular infrastructure.
You raise a good point about what those first steps are to this journey. and some of the pieces in terms of how that transition happens. I want to kick around a couple questions about how operators actually make this transition. And Ezra, I think you talked about some of the initial pieces about understanding how to build platform trust and some of those pieces. But what should operators consider first in their journey towards a more open posture for their RAN environments? And I don't know, Sunil, do you have comments about what are those directions and what are good places to start?
Yeah, again, I think there is probably two cases, right? There is, like, let's say, greenfield operators. Some of our experience with the greenfield deployment, obviously, it's much more straightforward. We really can build a network with all those right security features. And their basic assumption, what I have seen is really kind of you start with a completely zero trust model where you don't trust anything. So basically, there are in standards, sometimes you say this is optional, or say maybe some operator will say, okay, like, this is my core, like central data center, it is already secured. You don't need to enable right security between these two endpoints. So you don't really make any assumption. You kind of start with zero trust model, and overall that will bring a better security because you kind of started really securing each and every right pieces and each and every module. So right, make sure that everything is really secured rather than just making assumptions, right? So in the greenfield cases, basically, right, you can really start building from scratch these things, and we have that experience in building some network with that level of security, which is sort of unprecedented compared to right whatever is currently deployed in many places. But for an operator who is already deployed and who is really trying to move to, let's say, an OpenRAN and a virtualized model, maybe there are small transition, right, you can really do, right, as the speaker earlier talked about, right, really securing really the infrastructure and the whole layers, right, when they really start building a data center or right, these virtualized infrastructure, they can really start securing the hardware to the boot, to the guest OS, even right the virtualized application or containers can be secured. So there is really readily available technology right now. That's a good thing. It is really sometimes coming from other areas, right? Web world and other world it is coming. Yeah? So there is already like proven and well used, widely used technology available. It's really a matter of really adapting it and really using it, right? So you don't have to reinvent many of these things because it is widely used in other fields, not in the service provider area, right? So yeah, the transition path is there for greenfield as well as for the existing operators, but they are really need to really prioritize and use it, in my opinion.
I mean, not everyone can be a Rakuten, although we do see more of that sort of model evolving. But clearly, the much larger case is that existing market in which are existing capabilities in that transition.
Yeah.
So, how should operators expect to expand their RAN ecosystems? Is this something where this is primarily procurement? They need to be opening to a wider set of potential partners out there? What should they be looking towards in terms of expanding and integrating that much larger world?
Yeah, Eric. Traditionally, it was like a one neck to choke, and so, but things are opening up quite a bit. So many new players have joined, and I think that gives a lot of choices. So whether it's a radio, whether it's a base station, or there's a software, so you can even have a disaggregation that the hardware coming from some set of vendors, and then the software coming from some of the newer startup companies or even the traditional companies, and then the overall the O&M piece. Okay, so what is happening, and then dovetailing into something the earlier panelists talked about, a lot of best practices that IT used to do, the basic stuff, secure the hardware platform, protect the data, secure the workload, secure the transportation elements, are getting into it. Even in the existing environment, brownfield, not just greenfield environment, a lot of those technologies getting into it. And then ecosystem diversity that is growing is giving a lot of options. So the way they are going, the operators to the transition to OpenRAN, is happening through in a very systematic way. Whether it's, you call it Rakuten for greenfield or an existing operators like Telefonica, who announced just yesterday some activity on this, as well as Vodafone or even Verizon. So they're doing trials first with multiple different vendors, try it out, and then basically going to plan on deploying. First regular MIMO, then massive MIMO. So there are a lot of activities happening in tandem in steps to prove out these pieces. So there's a deliberate effort to actually go learn and actually then deploy.
No, that makes sense. And in terms of that transition, that in order to leverage those benefits, they've got to make that shift and actually get to that new standing and that new posture. I want to remind our audience, please send in questions. We've already gotten a few. Firewall question. We've got a couple others that are in the queue that we'll start to answer as we move forward. Just use the Q&A button down at the bottom of your screen, and we want to make sure that we've got this great set of panelists. We delve into whatever your particular areas of interest happen to be. And I want to... go ahead.
Sorry, I know, just adding to Udayan's point, right? To move to a cloud-native model, you need to adopt the principles of cloud-native model. So, taking on the smaller, trials, POCs, be making incremental changes, and then learning through those incremental changes to, scale further in the infrastructure is a strategy that seems to be working for many different brownfield sites. And in terms of adoption of OpenRAN, I think, these vendors, different vendors, partners like ours, on this panel, right, coming together to show that this has been pre-integrated, you can go try it, and then you want to expand on it, you can then do that and add more components to it, right? That's what really is the recipe for success in terms of deploying this OpenRAN infrastructure.
Well, we talked about the cloud-native capabilities and some of the benefits that come from a cloud-native operating capability as we were starting out. But I'd like to dig a little deeper into that. As you're identifying, that starts to give some operational agility. It starts to make that shift. Is that an area where operators should be focusing first, establishing a more agile infrastructure? And what are those steps that they can take to actually integrate those capabilities? And again, I'll throw this open to the panel for those that have got thoughts. Absolutely.
I totally agree there, which is adopting those agility principles, creating the pre-prod environment to actually push to a prod environment where they actually do the integration from different vendors in terms of software. Because the world's moving towards a disaggregated platform, right? Disaggregated infrastructure, where the hardware's coming from one, the software's coming from another one, there's another piece of software that's coming from a third, and then you have a radio environment that's probably mixed. So all of these need to be, pre-integrated, or you need to have some sort of a CI pipeline established, where you actually do that work in your lab and then start to continuously push out to a prod environment in terms of how things are done. Those are the principles on which cloud native development has operated for a very long time. And doing that makes a big difference in terms of how telcos can actually build and deploy this.
Well, and you actually are speaking to, I think, is that's the root of another of the questions that have just come in, which is why has it taken so long for this technology to be deployed in mobile networks when clearly the principles have been around in IT for some time? Well, yes, cloud native capabilities and some of the benefits, everything else that you were just talking about and Udayan had identified have been clear, but realistically, we're in an environment in mobile networks that's been pretty risk averse, and I think in traditional ways of implementing technology, there have been challenges to assure that risk is managed in terms of rolling out capabilities. But as you were just talking about, some of the benefits of being able to actually have a pre-production environment in which you can start to prove this out. And that's been hard to do, both when you've had physical environments and when you've had a single vendor that's controlled a lot of the elements with which you're working. What are some other aspects of this that could be influencing this, and what are things that are holding back traditional operators in terms of this transition? I guess we, as we were talking a little bit before the call, we seem to be at the point at which the floodgates may be opening as confidence is building, but is that the next step for this? And again, we'll take it from any of you in terms of thoughts on this.
Yeah, on that one, right, one of my opinion is the team, right, the operator, service provider, they need a different set of skill set and technology to really take this kind of journey. And if you take a traditional like a Verizon or AT&T, you probably need to really go and bring the different kind of team and right different culture and different thinking. And sometimes it is really that culture which is really stopping them, right, to really take this kind of path, because this is completely like different technology. It is done in web world in other areas, but not in the service provider, right? And what we have seen, at least in Rakuten, is really they have brought a lot of different skill, right? Different type of people who can really do this. And these are not traditional, right? Those are not people coming from traditional, right, service provider world. So that is definitely an area, right, where, right, if a traditional operator needs to do this, they had to really bring in this kind of people who has this kind of skill set actually to really start doing this work.
And so there's a staffing and a team component to this, so that you've got to get sufficiently good at actually operating in this way as well.
Retooling is important in general, right? There's this skills, staffing, there's also process. We often ignore that. We need people, and people need to learn how to adapt to these new processes. So yeah, those are actually bigger challenges than actually just throwing money, CapEx or OpEx at it.
And so it's developing some of those core skills on top of it.
Yeah.
All right, well, I want to be mindful of time, and actually we've got a whole bunch of questions that are coming in. I want to make sure that we've got a chance to actually get to each of these. An interesting question right off the top of this. If this technology is proven out by Rakuten or others, how incumbent operators, will they have to scrap and rebuild networks? Which is a great thought about sort of how we make this transition. So I think one of the things we've been identifying is that the scrapping is not the question. It's how you make that transition. But yeah, go ahead.
Yeah, scrapping is not the, how do you make it, coexist with the existing network and as this gets replaced. So I think that's why, greenfield companies like Rakuten and others, it's easier for them to actually quickly design and deploy, which basically the time factor was quite, the period is low in case of Rakuten. But think of what is happening in Verizon and Telefónica. So they were, targeting one portion of the network, slowly introducing it, putting it into their overall operations and management schemes. AT&T has own app and many others. So essentially injecting the cloud native elements of it from virtualization first and then getting to containers, coexisting with the existing nodes of SGSN and GGSNs of the previous generations. So that takes time. Nobody will talk about scrapping the network. It is all about coexistence of multiple radio technologies and multiple architectures, and then slowly the traditional elements are getting, as I say, enhanced and upgraded to the new architecture. So that's why it takes time also. Why it takes more time? Because it's a process to prove out.
Yeah, and I think we're starting to see. Look, that somebody has to be the catalyst, and I think we're starting to see now. Some of the operational environments where, as my colleague had mentioned, things need to be proven out, and they're being proven out, aggressively. I think there's been a number of us who have written white papers and things along this line describing kind of a migration path and strategy and things like this. But the net of it is my colleagues have all brought up good points around what we there is a people, process, and tools and a skill transition kind of thing that needed to happen, and then just to prove out an interoperability kind of thing. There's been a there's the commercial side of of how to integrate to a single or couple vendor approach. I think all of those things, the industry is bearing those out now, right? It's happening. Albeit, and the cool thing about that is there was a question in the panel around, well, what are the weaknesses of the Rakuten approach? I'm not sure any of us are on the call to discuss a specific, implementation weakness there. But I think what can be gathered out of that, though, is that now it is a industry-wide, consortium-wide approach to look at the overall threat surface, which has been very healthy for the multiple vendor implementation through this effort, right? So there are and the breaking of the decomposition of the solution into multiple layers has led us to look at each of those layers, the cloud native approach, the NFVI approach, the different approaches to the trust approach. Different parts have led us to to what's now resulted as a much more agile look at the different layers of securing operationally and otherwise the solution at hand. So I'm delighted to see a lot of the questions around the advantages of and disadvantages of the approach here. I think from when we look at what there's always early leaders, and when we look at the advantages and disadvantages of what Rakuten have tripped over now as a result of the work, and others as well in the industry, that's where we are. I think I'll leave it to my other panelists to add, but I think that's kind of where we are, right? And there is a natural migration of this, and you're seeing very much non-traditional telecom providers involved in this as well, which is bringing some increased focus and energy on what we're doing here.
Yeah, go ahead,
Eric. Just one data point. If you look at what drove the adoption of virtualization, it was the LTE EPC virtualization. And a lot of providers have learned through that in terms of first deploying it in the core, virtualizing the EPC, and I think Udayan or somebody else brought up the point earlier, Sanil I think brought up the point earlier around the coexistence with SGSN and GGSN with the LTE EPC. Now, if you look at the same thing today, a lot of cloud-native conversation is being driven through the 5G core availability. If most of the 5G core implementations that vendors are putting out is in containers and uses Kubernetes to orchestrate, is a microservices architecture, which is truly, adhering to the principles of cloud native. And what is going to happen is, I think this will drive another conversation, another, a learning experience in the industry, both from a vendor community as well as provider community, through the 5G core adoption, as people start moving from the NSA model to the more SA or the 5G core as a principal anchor, even for the NSA model, going forward. And I think that will provide a huge learning experience for everybody, so that that can proliferate further down into the infrastructure towards RAN, towards other areas in the telco cloud space.
It makes sense. We start to proliferate because they're getting good with the low-hanging fruit within the core, building those skills. I think one of the things, as Mike was saying, it's just building a lot of those skills and capabilities to actually be able to operate in a cloud-native mode. I've got one more question I wanted from the audience I wanted to answer that I think is pretty straightforward. In the old model, a lot of the value was with bespoke hardware. In the future, who will capture the value? My take would be we're already starting to see that transition. So we've got even a lot of the established players in the RAN market moving towards more COTS-like capabilities. But I think the value is going to move to where there is innovation. So it's going to be in those areas in which, rather than simply selling physical boxes, it's shifting towards the licensing of the innovative technology that's actually driving a lot of these capabilities on top of it. Other thoughts on that, Bradley?
Yeah, I think value will be captured in many different areas, especially on the IPs, the algorithms, the software. How do you do a better channel estimation or MIMO? And I think of those areas. And a lot of IPs can be created, and then this will free up a lot of developers in general to worry about the platform and physical platform, which will be open platform, cost hardware, and then basically add features and functions and security elements on top of it. So not only the IPs on the algorithm, on the radio specific stuff, whether it's in layer 1, layer 2, and others, but also on how do you protect it, how do you create the trust, the stuff that we have been discussing for a while now. So all around that place is where IPs can be created.
Well, and to your point, it's much like how we've seen value creation expand within cloud native approaches. You open those doors, you provide more telemetry. Now you've got folks who can now digest that data and do new and interesting things with it. Lots of different opportunities that opens the door for. And I wanted to get one final. Oh, go ahead.
No, just to add to that one, now we are seeing also companies started thinking about and even learning from the cloud other the startups to actually add machine learning on top of those. So you talk about telemetry, so more data is exposed through virtualization, through the cloud native principles, and then your platform is visible to you. You can do a whole bunch of learnings, and you can do a whole bunch of machine learning elements and take actions in actually addressing a lot of the next generation of security elements, threats, and others. So a lot of value can be created on top of that as well.
Because you've now got open interfaces from which you can pull all of that additional information. You've got additional standardized points in which you can observe all sorts of good things that you can extend beyond that. All right, we've got other questions that I want to...
Right. Yeah, just
go
one point quickly. There is a tremendous opportunity for automation, which is really enabled by this all virtualization and openness, and it really goes towards OpEx reduction. So much automation you can do, and that's an opportunity for value creation, right? And that we have seen in Rakuten also, right? There's so much things you can really automate, and there's opportunity for companies to do that and really do an end-to-end automation for the whole thing, which is significantly reduce the OpEx and human intervention needed in the network.
Well, and that's a really important point, which is the automation actually has the ability to address a much larger footprint. It's not the sort of the fragile, brittle capabilities that are tied to individual aspects. You actually now have the ability to be able to handle and deal with the much broader capabilities of the infrastructure as a whole. Because you've got standardized interfaces across that entire environment. So your automation efforts can actually be much more comprehensive and, as a result, much more effective. I wanted to close with one final question. How does this align with the ORAN initiatives? And again, any of you want to make a specific comment to it? There are lots of different opportunities in terms of how operators can move forward. And certainly having efforts such as ORAN are one way to frame a lot of this discussion.
Yeah, and quickly from Orchestra point of view, right, we are aligning as much with ORAN. But when we started, right, ORAN itself had gaps, and it was not fully defined, and wherever it is needed, we had gone with something like fill gaps kind of things. But ORAN is also catching up and really standardizing and putting more details. And as with that, we are also aligning as much with ORAN. And I think to have a standardized interface, because we are bringing many vendors together, it is beneficial to really align with the standards, so that really this flexibility of using multiple vendor equipment will be enabled with that.
Yeah, ORAN just did a plug fest in December. So brought in a lot of the companies and tested some of the interoperability between RAN, between the base station and the radioactive, and the radio equipments. And the specs are also getting published, and they've started security subgroups to address each and every layer of security. So there are a lot of good activities happening, and and the companies are aligning towards what OpenRAN is doing.
Yeah, two areas of focus for us in the ORAN space is WG6 and the ORAN SC. What in terms of management and orchestration, right? What does it look like? How do you define the management security capabilities? What requirements does it impose on the infrastructure element? And then how can you secure that? So that's an area of contribution and work that we've been involved in. And then the ORAN SC in terms of the software committee, looking at the implementations of some of the software components to do it right in terms of how do you disaggregate some of those software components and do it in the right way so that state can be appropriately managed. Secure profiles can be appropriately managed so that you're not always requesting root access to the node, and that you can actually operate in namespaces and C groups and so on and so forth. So these are some things that we've been working with our partners to ensure that that's the right model and right way as they write more software and disaggregate them so that security postures can be improved overall.
Yeah. A good framework from which to work with, and a lot of interesting opportunity coming out of the working groups themselves. And I'm actually, while I said I was going to close out, we do have one more last interesting question in the end, specifically about some of the mechanics of security. It's how you ensure isolation of the nodes in a virtualized environment for access and core, so that if one node is compromised, how do you prevent it from affecting the other nodes? And this, I think, gets back to some of the fundamental security principles in the cloud native, in which you've got the ability to observe how individual functional elements are functioning, but also the fact that you've got opportunities in an open environment to be able to actually inspect a lot of that conversational traffic going back between nodes. Is that covering what the question's heading towards?
So, I mean, there are deployment models.
Go ahead. Sorry, you go ahead.
Sorry. I was saying there are deployment models and principles in terms of what you would adopt to ensure that you have the right security postures and security profiles implemented in the system. Now, if you know that a certain node has been compromised in the system, there are ways to isolate it as part of the infrastructure and the platform. But it depends on where within the different layers of security that I earlier spoke about, where has it been compromised in which layer, and then you'll have to have some level of correlation function to ensure what the impact is, so that you can take the right set of measures. There is a lot of telemetry data that's available from an infrastructure layer. There's a lot of telemetry data that's available from an application layer, and I think you really need to go and look at those in order to ensure what is that needs to be shut down or isolated or moved around.
And fundamentally, it's the visibility and transparency that gives you an enhanced view and better situational awareness of what's there. And Mike, it sounded like you had a comment on that as well.
No, I think it was covered by my colleague. I think the net of it is there are best practices very quickly coming up, connecting the different layers of the architecture around the use of segmentation and application of policy to it. What's really interesting in seeing some of the early implementations is that you're starting to see, for example, segmentation at the segment routing label stack level. There's segmentation at the cloud native virtualization level. There's segmentation at the orchestration and automation level, and finally at the packet core level, where these things need to be, sometimes have traditionally been taken, a bit separately. And we're starting to see implementations where these things are brought together to deliver a stack-wide capability. And I think that type of integration and automation will continue to evolve. It's one of the exciting things about this approach. That's really where I was going to go with it.
And then getting back to one of the fundamental benefits that openness provides. Well, with that, we're at the top of the hour. I want to bring this to a close. Thank you all very much for your perspectives. Thank our audience for the time they've spent with us today. and look forward to extending this conversation. As Kristen was saying, this is going to be also available on demand. So we hope that you'll get a chance to catch up with this, and we'll answer any of the unanswered questions as we follow up with this as well. So thank you very much. We appreciate all the time for both our panelists and our audience.
Thank you.
Thank you.
Have a good day, everybody.